My name is James Corbett, and I'm a software developer at Lawrence Livermore National Laboratory. I work on the Flux Resource Manager and also on the ExaWorks ECP project, which Parsl and Flux are both parts of. In this presentation, I'll be talking about a new executor class added to Parsl a few months ago called the Flux Executor. So not only will be familiar with Flux, but it's a next generation resource manager. By resource manager, I mean a program for requesting resources and launching applications, examples of which include Slurm, IBM's LSF, and Argonne's Cobalt. And Parsl resource managers underlie many of the provider and launcher classes, like the Slurm provider and the SRun launcher. And for the past few years, Flux has been slowly taking over Lawrence Livermore National Laboratory, even though it isn't running system-wide on any machines. That might seem a little strange, or maybe even impossible, because with most resource managers, you have to use whatever the system administrators have installed. For instance, on Oak Ridge's Summit or Livermore's Sierra, you have to use IBM's LSF. And on ALCF's Theta, you use Cobalt. But Flux provides you with another option. You can request an allocation from the system resource manager, whatever that happens to be, and then launch Flux within that allocation. From then on, you talk only to Flux and can completely forget that the system level resource manager exists at all, at least until your allocation comes down. So at Livermore, Flux has been in production use for 4 years now because users have been making the choice to use it inside of their Slurm and LSF allocations. Flux is now on the final slowest mile to replace Slurm across all of LLNL, and the plan of record is actually that Flux will be the system resource manager on LCAP, which is the 2023 exascale machine planned for Livermore. And in fact, Flux recently won an R&D 100 award. Actually, that was just this month, which is why I have a little image of it on the right. So from a user perspective, the Flux Executor is a Parsl executor that, like any other. It has a few unique options that you can read about in the documentation. I have a link to the documentation at the end of my presentation. But it implements all of the common functionality. From a developer perspective, though, the Flux Executor is pretty radically simple. The scheduling execution framework that most executors need to implement is replaced by simple calls to transform an app into a Flux job, submit it to Flux, and be notified of the results. So you might be wondering, why would I ever use the Flux Executor? I mean, Flux sounds like a great resource manager, but why use it? Parsl already offers a number of executor classes, but most of them have different areas of specialty and intended uses. The Flux Executor specialty is workflows that are made up of applications with highly varying resource requirements. For instance, say you have a workflow that consists of running a CPU-intensive MPI simulation and then running a GPU-intensive analysis on some of the output of that simulation. Or say you have some apps that will take dozens of Summit nodes and others that will take only one core. Flux will handle that kind of workflow seamlessly and efficiently because it comes along with a first-class scheduler, which is highly configurable. That is something that most of the other resource managers like Slurm and LSF, they have some scheduling functionality, but it's not at the level of Flux. Also, Flux provides a portable way to launch MPI applications, since it can run most flavors of MPI. Flavors of MPI meaning like MPitch, MVAPitch, OpenMPI. One major exception is last generation Cray MPI. That's the default MPI in ALCF's Theta and Lanels, Trinity, and Trinitite. It's not a fault of Flux. Due to some unusual modifications that Cray made to their MPI, Flux cannot support it. So at the moment, if you want to use the Flux Executor on a machine like Trinity or Theta, you have to build all of your applications with another MPI that Flux does support, like OpenMPI, which can be a pretty big hurdle, but I have to mention it because yeah. So each app that you pass to the executor can specify a number of options for requesting GPUs and MPI ranks, and also for tweaking their placement and distribution. I won't go into the details. You can look at the documentation. You can request more ranks. You can request more cores per rank, stuff like that. And by default, every app will get exclusive access to the CPU and GPU resources they request. That's just a Flux policy, but you can change that if you want. So some future work we have to do on the Flux Executor. The Flux and the Flux Executor are both part of the ExaWorks SDK. So actually, the Flux Executor is tested inside of our special SDK CI, but the ExaWorks SDK isn't available everywhere. Actually, it's not very widely available at the moment at all. But once it is, that's something that the ExaWorks team is actively working on. Flux and the Flux Executor will be available. So we're aiming at most big HPC sites, which would certainly include ALCF, Oak Ridge, and so on. But if you're at Livermore or Oak Ridge, there are already public Flux deployments you can make use of. And if you did want to build Flux yourself, it really doesn't have many dependencies. A next major ticket item we have to work on is getting Flux into a tag Parsl release. That will just be waiting because it isn't in Parsl 1.1, which is the latest release as far as I know. And the last thing we want to do is run some benchmarks on a large machine like NERSC's Perlmutter, which is their or an early access machine, but I think it's going to be a fairly large one. And we have users at NERSC who are interested in using Flux and also Parsl. So that's all I have. Here's some links to various pages that are relevant. Like if you want to learn more about Flux, you get the Flux's homepage, their documentation. If you want to look at the Flux Executor interface, I have that up on Parsl's Read the Docs page. You have to look at latest because it's not in 1.1. Yeah, and we have some example configurations of how to configure the Flux Executor run on Livermore machines. And yeah, that's it. That's all I have for you today.
All right. Thanks, James. Congrats on the R&D 100 award. I have a quick question. So if a new user wants to try out Flux with Parsl, what would be the best way to get started? Like, would you go to a LLNL machine, or is there a specific machine that's like more friendlier and easier to use?
Well, it's certainly the easiest way would be to use the Flux deployments that the Flux team has made and supports. So that those are on Oak Ridge and Lawrence Livermore. I know the path. So at Livermore, I'd be happy to help anybody. Oak Ridge, I would need a little bit of support from my team members, but there are because I didn't make the deployments, but we do have publicly supported versions on Oak Ridge and Livermore.
From the point of view of developing this, I'm curious, was there anything in Parsl that was not that didn't really fit what you were trying to do? Were there any changes that were needed, or did this kind of just plug in really smoothly?
I would say it plugged in pretty smoothly. It wasn't entirely a smooth development process because I had to learn a lot about how Parsl worked, but like once I knew how it worked, it was a smooth plug-in process. I didn't have to change much of anything at all, I don't think.
Okay, thanks.
Yeah.
Question here. James, is anybody running Flux in the cloud? And if so, are they doing it native or over another cloud scheduler?
There is actually a big development effort at Livermore to integrate Flux with Kubernetes and make Flux the Kubernetes scheduler. I mean, not the Kubernetes, but a Kubernetes scheduler. I'm not sure exactly how far along those are, but certainly Flux in the cloud is something that the Flux team in general is very interested in and is working on all the time. I don't know how many real-world success stories there are yet, unfortunately.
Okay, and does Flux for the cloud have any elastic, perhaps power management-based facilities for doing elastic node allocation? Like such as Slurm, which Slurm uses a power management approach to manage cloud elasticity. I was wondering if Flux has anything similar.
Like resources coming online and going offline and changing the overall size of Flux.
Yeah, changing the size, for example, of a partition or the Flux equivalent of a Slurm partition. as,
I see.
as
I think
needs, as load or demand for that partition grows and shrinks?
I know for a fact that there is work in progress on that, because there are other users that have been interested. But I don't know that I can point you to any. I think as far as I know, it's still a work in progress.
Okay, thank you.
But that I do know that the Flux team is working on it as well.
That sounds good. Thanks.